Before we end this section, I want to discuss a few advanced data options with you. The iMusic app is using archiving to store its data, and this works perfectly fine in this app, and frankly, archiving can be a great solution for a whole lot of apps. But if you're managing a more complex data model, or need to manage a large amount of data, it probably isn't going to scale up to meet those needs. Luckily, you do have more advanced data options available on the iOS platform, and in this lesson we'll briefly cover those additional options. The first is SQLite. SQLite is an open source and very widely used relational database. The iOS platform provides an embedded form of SQLite, and any iOS app can make use of it simply by linking your project with the SQLite framework. It's a fast, lightweight database, but also quite powerful. The core features that you could perform with a large database like Oracle or DB2 are also available in SQLite, but in a much smaller, lighter weight package. The framework provides a C API for managing tables and issuing queries, but this is a fairly low-level API and requires a significant amount of code even for fairly simple operations. I would recommend checking out this open-source package called FMDB, as it provides a convenient Objective-C wrapper around the SQLite APIs, which can greatly simplify common operations. Now, of course, in order to use SQLite, you need to have a good working knowledge of SQL. If you're a regular Oracle jockey, then this may be second nature to you, but if not, learning SQL will be one more thing to add to your list of things to learn. Although SQLite can be a great choice, one thing it won't help you with is managing your object graph. Managing the often complex interrelationships between objects will have to be done manually by you. If you have a more complex, more involved data model, then I would recommend you turn to Core Data. Core Data is what Apple refers to as an object graph management framework. It provides the management and persistence of complex data models. Model objects are subclasses of a class called NSManagedObject, and these object types live within a managed object context. As you query for and modify objects or traverse complex relationships between them, Core Data can manage all of that for you. Xcode additionally provides a graphical tool to build and manage these managed object models. This tool allows you to define your entities, manage the relationships between the entities, define their properties, set validation and deletion rules, and all of this can be done graphically within Xcode. Core Data also integrates with iCloud. This enables a whole host of possibilities that wouldn't have been available previously. This framework should be considered whenever you're managing large amounts of data. As Core Data is frequently backed by a SQLite store, it's very fast and very efficient, but provides a nice layer of abstraction over the details of working with SQL. Or if you're working with more complex object models, Core Data knows how to very efficiently manage complex graphs of objects and can simplify working with your data model in these cases. One thing to be aware of, however, is that Core Data is fairly complex, with a large conceptual footprint. Although I think it's the right choice for many applications, I would carefully consider the implications of doing so before diving in. In this chapter's lessons, we've worked with archiving. This is a good choice for our application and is often a good choice for many apps. For small, simple data models, this is often an easy-to-adopt solution. But of course, the iOS platform also provides a number of more advanced options to meet more complex data needs. SQLite can be a good choice if you've got a fairly simple data model but are managing a large amount of data. If you're managing a large amount of data and have a complex data model, then Core Data is usually the right choice.